Welcome to ETHDam, to ETHDam, to ETHDam, to ETHDam, to ETHDam.
Yes.
Amazing. Let's welcome our next speaker. This talk is Enabling Standardized Executions Through Modular Accounts. Thank you very much.
Well, nice to meet you, everyone. My name is Eugenio Reggianini. I'm gonna go through this definitely less technical speech and more, let's say, product and business and inspirational speech about research that I was honored to lead with another group of very smart and interesting people about how to merge usability and privacy in a standardized way for on-chain services. So let's start from a little bit from market perspective, right? So we see a couple of trends coming from users. Users want to do more things and more complicated things on chain, essentially. At the same time, we are embracing with features which allow us to aggregate signature, doing more things on chain. And we see the need for embracing cryptographic primitives to reduce the amount of data which is posted on chain, and for some cases also ensuring that some level of computation is executed in a private environment. This is to ensure compliance and to provide a more efficient user experience. So how we can achieve this? On one side, in terms from UX perspective, we can enable contract-based account services, which can be plugged with different module functions. This is a good combination which combines flexibility and usability. We have seen the adoption of contract accounts-based services, enabling for batching transaction, enabling for social recovery, for meaningful purpose of doing things on chain, which were not possible before. On the other side, privacy is actually addressed by different cryptographic techniques, which allow us to reduce the amount of data which is posted on chain, to run cryptographically in private environment, in trusted execution environment, but also on private computations, a list of selected action that the users request us to do on chain. So what we envision for coming features that a blockchain-based account should having. An identity contract. Why? I need to be able to prove that I'm requesting this action by myself, and so for essentially anti-Sybil protection. I need a contract account which can be flexible to execute different functionality which the user are requesting to me as a service provider. And a third one, a privacy feature, which enable to essentially provide scalability, to solve scalability issues in reducing the data which is posted on chain, but also in addressing full confidentiality of certain action, especially when we are applying specific use cases in a competitive environment, which is probably the case for public permissionless network, when everybody can propose new things. So what we are giving really as a user into this concept, we are giving an identity which can coexist with privacy and can coexist with, I would say, flexibility provided by contract accounts and their own capability, signature aggregation, modularity, batching, and so on. Why the user need this? Because at the same time, we can enable and improve the user experience. We can support multiple target of markets, from retail users to enterprise users, and also we take care of privacy from data management perspective. This project has started a few months ago. Started as a research whose results I'm actually showing here today, with the support of a couple of communities and which grouped a list of professionals, which I'm honored to represent here. And we are slowly going to a development environment where we are going to test essentially this new set of features for a blockchain account. And we are always open to, if you're interested, to collaborate with us. Our general user flow would look like. That's actually where I think we can spend a little bit of more time. Essentially, these three product features, they are combined together. The first one is an identity contract, as I was mentioned before, which is used by user to create attestation which are proven on claims that they request to execute action on chain. And this can be taken by smart contract on-chain attestation, by NFT minting, or soulbound token mintings. So essentially, I am creating my on-chain identifier state for enabling me to expressing what I want to execute on-chain as a user operation. That user operation, then it is relayed on a mempool, and which is assembled by a bundler and interact with the smart contract account capability. The smart contract account capability validates the user operations, generate a node for the extended transaction, and then communicate with a set of modules that are essentially having the goal of minimizing the data sharing, which will be authorized on the network, and manage the executions on a private computation. Using by that, so a ZK validation module, which verify the proof of the on-chain identifier state generated by the identity contract, and a fully homomorphic virtual machine, which actually execute on a privately basis the user operation generated by the user, authorized by the signature verified. All this transaction payload is transmitted to the contract entry point that then at the end execute for the users on blockchain networks. Which kind of use case we can empower with this setup? First of all, fully confidential voting. We have seen that so far we have been developing on-chain governance systems, but let's say sometimes the level of engagement in the on-chain government has been lacking. Why? Because of lack of harmonization and fully privacy on operating and casting voting operations. Why this concept could reduce the gaps, and we think that can support the engagement on on-chain governance voting procedures. Because on the identity contract side, the members can actually provide a system that establish anti-Sybil mechanism to prove that they are authorized member to cast their vote. With fully homomorphic environment, they can actually execute their confidential voting power that is encapsulated in their token holding position. In that way, the contract account will, you have to think that will generate a sort of ballot in which an accumulated power of token holders who voted to support one decision will be able to match the threshold for a specific proposal or not, without fearing of being traced back in terms of if I'm without homomorphic encryption, if my voting capability, my voting power would be able to post it after the execution of a proposal, potentially because we are in a blockchain environment which is fully permissionless, we would be able to see who actually voted by associating the voting power with the nullifier. The changing environment from voting to trading, with different logic, this kind of setup can enable a broader audience of traders, which not only focus on business dynamics, but also on regulatory requirement to access trading venue. In this context, the identity contracts takes care of the onboarding, but also of the compliance requirement, which are enabler for investors, not members anymore, to access trading accounts. And at the same time, the fully homomorphic encryption make sure that the trading KPIs, which are requested by the user operation, are matched in a private environment by the trading account without disclosing the internal trading operation that has been executed in order to achieve that results. And thirdly, is what I described here, a supply chain / NFT distribution environment. Reframing. There is an environment where myself as a buyer account, I'm going to a procurement process for a grant, for a program, for different reasons. I need to make sure that my supplier meets the procurement requirement that can be verified with zero knowledge cryptography in order to get access to this procurement process. And at the same time, for a matter of competitiveness, if I get selected and awarded with for the project with the money, I want to make sure that my award selection gets run privately without providing public knowledge also to competitors that I was selected and keep my competitive advantage. So to conclude, what this research, I think, matched to discovered, by combining user experience and compliance and privacy, we into an account set of features which combine contract accounts and different cryptographic techniques. We managed to aggregate messages, willingness of the users operations. We are able to verify in a granular way the signatures of each of the aggregated signatures of the users, and we are able to execute those requests on chain on a private environment, keeping the permissionless network in a competitive space, but taking care of the compliance requirements. I think that's all, and I thank you.
Thank you. Any questions?
If not, that's...
All right, thank you very much. That was really good.